Thank you for the introduction. As noted, the title of my talk is Breaking the Bottleneck from Past Programs to Past Projects. This is largely a summary of my experiences using R, why I choose to use R, and how I've used it in a professional context. Before we begin, a couple of quick disclosures, if you will. First of all, my phone is on flight mode. Is yours? Secondly, I'm casually employed with Deloitte, but just to be clear, tonight I'm representing myself as a private citizen, so don't consider anything I say to be the formal or official viewpoint of Deloitte. My opinions are mine and mine alone. If you have any questions, please save them to the end, and I'd also like to thank Alex for agreeing to be my acting manager, if you will, for certain parts of this presentation. So starting about myself, I am used to living in multiple worlds, if you will. I have a PhD in electrical engineering, and I have an MBA. And those two can be pretty different, and I'm an American, I live in Australia. I know what it's like to have 2 feet in different cultures, and to simultaneously be both and neither, which logically makes absolutely no sense until you've been there, and then it's perfectly clear. I've worked in various industries, defense in the United States, banking, primarily credit risk, biomedical engineering, and teaching. And you look at that wide range and think, well, that's a pretty big range and they're all very different. How is all of that one continuous journey? And if I think about it in an abstract sense, what really motivates me is I want to have a measurable impact. So when I was in defense conducting flight tests, when I was teaching, when students would come up to me afterwards and say, hey, I learned a lot in your class. In credit risk, getting my models implemented rather than the models themselves. I was in academia for a while, publishing papers and pushing the theoretical limits isn't what motivates me. What motivates me is making an impact and seeing my work come to fruition. So if you learn nothing else today, I'd like you to take a moment at this R users forum and ask yourself, what is it about R that you enjoy? Is it the programming itself? Is it the open source nature, the community, etc.? So, because one of my goals is to have a measurable impact, well, what are my goals for today? My target audience is mainly beginning data scientists or beginning R users. If you're a master at R, this may seem a little simple, but I hope the concepts may be new for you and may provide some insight into using R in an industry environment. This is an overview of my experiences and insights. I'm going to be giving an example which is based on a true story, but I'm omitting the names to protect the guilty. And reason for this is there's this saying that wise men learn from others' mistakes and only fools from their own. So hopefully you'll learn enough about my mistakes to learn something because you are all truly wise. One of my goals is I want to use open source tools with freely available data so that all of you can go and reproduce this by yourself. I gave a version of this talk in Melbourne in 2017, in January, so almost 3 years ago. For context, that is the same month that this book was published, R for Data Science. So when I first gave this talk, R for Data Science was a relatively new concept, a relatively new thing, as that book, which is quite seminal, and if you don't know it and you want to use R for Data Science, I highly recommend it. It's available for free online. And finally, I want to provide some recommendations, or in the language of data science, I want to give actionable insights. So if I'm talking about data scientists, this term gets thrown around a lot, but what does it actually mean? Well, one definition is from this infographic, that a modern data scientist, which is the sexiest job of the 21st century, consists of 4 pillars. The first of which is math and stats. And for that math and stats, you can see the different things listed there, or maybe you can't from the back of the room, but it includes a lot of algorithms, supervised learning, decision trees, logistic regression. And if you consider the mathematics of it, that's one thing, but most of those algorithms today have been implemented in languages such as R. So in a sense, a lot of these mathematical concepts today become programming concepts. You need to know which one to use, why, you need to set the meta parameters, but oftentimes there's this automation to take complicated mathematical topics and turn them into functions so that programmers can use them. And the other main pillars are programming and database, including R, domain and soft skills, communication, and visualization. Now, as an infographic, I've seen different iterations of this, So it's kind of hard to put a date on it, but this one was from May 2017, or 2.5 years ago. In the problem I want to discuss, I've made certain assumptions. Again, I'm trying to use freely available open source data so that you can all reproduce it. And I want to focus on classification or regression problems where I've already done the initial step of having clear independent and dependent variables. If you're starting a job as a programmer, you may find that's not always the case. And I'm talking about CSV style data, which as a consultant, this is what many of my engagements are about. Someone hands me a data file and says, here, these are all of my independent variables, and I'm trying to predict this one. Go. So I'm not talking about big data, by whatever definition of big data. What I mean is that I can run this on my laptop, or if you'd like, on the cloud and near real time. And I'll talk about what I mean by near real time. Most of my experience is with large organizations. So you have multiple stakeholders, multiple teams, multiple metrics, different ways of assessing your work, of viewing your work, and oftentimes even identifying your stakeholders is a problem in itself. Governance around these things, who's the owner, who's the user, what are they using it for, etc. And ultimately they become political. And I've got a little survey that I've asked you all to think about in your heads. Remember, my goal is to have a measurable impact, to get my models implemented. In your work, who has the authority to make that happen? And how accessible are they? Now, I said this was based on a true story. When I first gave this talk, it was kind of in reference to my manager, who I could meet with daily. He was very accessible, no problem. Unfortunately, he didn't have the authority to say, yes, that model's good, implement it. It had to go to his manager. I've seen his calendar, it's full of meetings. To get to talk to him, there's a 2-week lead time. Even then, if he says, yes, that's go, that needs to be approved by a governance forum. They meet quarterly. If I were to build a model the day after their forum, it would be 3 months until anything happens. And so if you're a student, how often do you see your entire supervisory committee? If you submit a paper and it's getting peer reviewed, how long does the peer review process take? Think about these things with respect to this talk, but I'm going to use that 2 weeks that it was for me to talk to my N+2, the one that had the authority to say, I like this model, let's move on. So the one I want to talk about today is to predict median house prices from the Boston data set. It's a canonical data set. If you're using R, it's probably already on your machine from the mass package. And I want to decide if I want to use a linear regression model or a random forest. So you can imagine you're in some industry and they're already using linear regression. They've heard about the machine learning and they want to see if the random forest will be better for them. For this project, I've got some deliverables listed there. A recommendation, which one do you want to use, the linear or the random forest? The code, which I need to write. Documentation of results, so a summary, and then slides that I can give to my N+2 so that when he's presenting it at his forum, he's got all the information he needs. And I'm saying, let's pretend like this is a 12-week project. And 3 months to build a model is about right. Not unreasonable, shall we say. And if I look at the process I'm going to follow, it's something like this. You may have seen different things where you source the data, clean the data, build your model, etc. And I've done it in a tricky way so that they all begin with the letter D. You define the project, you do it, you decide, you document it, and then you're done. And being done is where I want to be. I want to see this model come to life and start adding business value. And if I consider the hypothetical problem I have here, predicting house prices, I'm at this point. I've scoped out my project, I know what I need to deliver, I know how long it's meant to take, I've got my data from the Boston, and now I need to write the code, etc. So I start doing it and I explore the data, and the Boston data set has a data dictionary. It's got no missing values. This doesn't happen in practice, or if it does, it's extremely rare. And when it does happen, life's good. It makes you feel like dancing, you know, proper dancing, dancing like no one's watching dancing. you know, dancing like Taylor Swift. And I wrote up the code. I was teaching myself the tidy models package, so I got everything written up in about a day. Code runs in seconds. This is based on my belief that I'm not big data. It runs on my machine. And I wrote it all up. It takes about 45 minutes to write it all up. So this is a 12-week project. I'll be done in 12 hours. I've got this. Now, in the previous version of the talk, everything I had done was in Basear, and now I'm using the tidyverse, and in particular, teaching myself tidy models. Everything is so much faster and so much easier. And so you get to the decide part of the process, and you have your meeting with your manager, and he says, you've done great work, and everything's great. And then he says, you've got this concentration of nitrogen dioxide in your model. Do you know how we'll measure that? And I say, no. So it looks good. It's a good model. Everything's what we need. Just pull out the nitrogen dioxide concentration because I don't know how we'll measure that. Okay, I can do that. So I go back to do it again. It's a few lines of code. And the tidy models, you update the recipe or recipes if you have different ones for your linear model and random forest. It still takes no time to run on my laptop. You refresh the graphs and the numbers, which takes 15 minutes, most of which is just being sure that you've hit them all, that you didn't miss a number somewhere. And then you, I guess you can try to make things more efficient, play with the color schemes, but otherwise you wait. And so if I look up how long it's been, it's about a day's worth of coding. Documentation has been about an hour, and the project's 4 weeks in. So I get to meet with my manager again 2 weeks later, and he says, great work, and life's good again. And then he says, he's been to all these meetings, and they're talking about the uses of big data, and so they need to include everything. So you've got that concentration of nitrogen dioxide. Could you put that back in the model? And now I don't feel like a relaxed panda anymore. Now I feel like an angry panda, because from my point of view, it's you want me to take it out, now you want me to put it back in, you're moving the goalposts and I can't deal. We're back to where I was on the first day of the project. And the project's half over. It's been 6 weeks. And I'm frustrated because the goalposts are moving and I'm getting contradictory bits of advice. My N+2 is annoyed because he has yet another meeting that he needs to plan in 2 weeks. And, more importantly, he needs to reserve some brain space for my project, in addition to everything else he's working on. My immediate manager is annoyed because he has to try to negotiate between the two of us to mitigate my frustrations and his. His peers and leadership team are annoyed because it takes 3 months to build a model, and no one's winning here. So if I go back and revisit my process here, I've gotten to the point of deciding, and I'm stuck. I can write the code, but I can't confirm a solution. I can't get formal acknowledgement that yes, this is the model we want. Let's move on to the next steps. So in terms of business usage, if you have your process and you find a place where you're getting stuck, that's the bottleneck. One way that I try to fight this is using Shiny. So rather than just having code that I write, here I put it all into a Shiny app. And so this first tab is my documentation, where I have a random number seed of 100. I've split my data between training and test 75-25. I have some, can I make this bigger, maybe? I have some parameters from a random forest. I've got the results from my training data, my testing data, cross-validation, right? So when I'm talking about summarizing my results, it's here documented. I can then move on to my data, but this is a simple EDA of all the different variables. And here's where I use Alex, who's graciously agreed to help me. I want to split my data between training and test. What seed should I use? Pick a number.
23.
23. Excellent choice. So when I type in 23, some of those distributions change. Now, do you want 23? Do you want something you want something a little higher? Maybe 24? Maybe 22? Maybe it'll change twice? As I go through that, do you want to change entirely?
Can we go beyond 100?
Yeah. What? You want like 2,200, 22,000?
22,000.
All that's happening is it's changing the random number seed in the background and splitting the data 75-25. Now I'm playing a little bit of a trick on Alex here. And the trick I'm playing is I want him to feel like he's in control of how the data are being split. In fact, he is. He's picking the number, the data are being split accordingly. But the reason why I want him to feel in control is because if you have the perception of control, you have a lower perception of risk. So now, my manager has a lower perception of risk in this model because I haven't picked a certain seed that I know gives me the answer I want. He picks it. If I look at my data and I want to consider individual variables, this nitrogen dioxide, should I leave it in or take it out? Take it out. All right. So let's take, if I mouse over it, tells me what the names of the variables are relative to their variable names. Because this is a web page, so I can put in things like tooltips, popovers. So if I want to give this to my manager so they can run it, I can try to make it idiot-proof. And so if you want to take out the nitrogen dioxide, we take it out. And then NOx is missing from my list of variables. Looking over it, there's another one that kind of concerns me, and that's the proportion of African Americans in a neighborhood. Do you want to use that? Let's remove this. I like this, because when I'm talking to him, what I want to do is I want to move the conversation from a technical point of view to an ethical point of view. When you talk about AI, there's a lot of discussions about bias in AI, discrimination in AI. And so when I have some demographic information, I want to pull it out, but I want him to say it. So if I look at these variables, my linear model, I'm removing variables that are correlated. And here I've got it at 0.6. Is that good? Do you want it higher or lower?
Let's move to
0.7? All right. Now when I move to 0.7, the colors of some of those might change, because now the ones that had a correlation between 0.6 and 0.7 are included in my linear model. So thanks. So in this way, I'm having the communication with my stakeholder. Do you want the variable in or out? You're in control of how it's split into training and test. You're in control over which variables we pick. You're in control over whether or not this model is going to be ethical about including or excluding information like race. And if I go on to start training my models, I can configure a random forest. Now, whether or not my manager is technical and understands all these terms is a separate question. But right now, my random forest is 200 trees. If I go to the implementation team and they say 200 trees, no, maybe 20, I can adjust that and see what impact it has between predicted and truth. Again, the green is the linear model, the purple is random forest, on the distribution of the residuals, or the errors, and the metrics in terms of root mean square, R squared, and mean absolute error. So even if I'm using this as a data scientist, I can interact with it. I can try to set my meta parameters and see what impact it will have on my results. And I'm not saying this is enough. In fact, I know these metrics aren't enough, but for sake of argument in tonight's demonstration, let's keep going. So I change some of these numbers, see what their impacts are. And after we agree with everything, I move on to look at my test results. And I can see what the metrics are for my two models there. And if I'm concerned, I can go back to my documentation, which is why it's in the same place, and I can check what my testing was when I ran it the first time versus with whatever interaction we've had. So I've gone from 5.88 and 2.93 to 4.76 and 3.73. And I can bounce back and forth. Now the awkward part comes as a data scientist when I'm looking at my root mean squared error in my test data, and my manager isn't quite sure what that means, but he knows that his metrics are assigned to that, so he wants to change it now that I'm on the test, and he says, I told you to take that nitrogen dioxide concentration out. Could you put it back in? From a technical point of view, yes. From a data science academic integrity point of view, no. But if you're preparing for these meetings, be prepared to have that discussion. And just in case there are some biases about that, I can go to do cross-validation, and not that 10 is necessarily enough, but so that this runs in. So in this way, I want to present all the information to my stakeholder, incorporate the feedback directly. And when I was saying this would run in the cloud in near real time, what I mean is that it's fast enough that I can do this in a meeting, and if it runs in seconds or tens of seconds, fine. But anything longer than that, so that it starts to get awkward as a data scientist trying to have a conversation with your manager, that's too long. But there's no firm timing on that. So while it doesn't work all the time, if I go back to my process, the problem I had was in confirming the solution. And now I have a means to incorporate feedback immediately and see what the results are. This is good for me because if they dither as to whether to include a variable or not, I can do it directly. It's better for my manager because they can get in the headspace of this model and deal with it now, as opposed to going away, dealing with all their other responsibilities, and coming back and trying to remember what's going on. But now I have a problem, because if doing that, I can confirm the solution, I might have another problem. And that is, even though it's all agreed and we've decided, I would need to do the documentation. And I don't want to be in a point where it's all agreed, I do the documentation, I meet with my manager in 2 weeks, and he's flipped again. So then it becomes a question of, well, can I reverse this? And it might seem a bit odd to say, to do your documentation in slides before you've had the conversation to decide which one. It's a little backward, but there are some tools to do that. So normally I do this with rmarkdown, and at this point I have a confession to make. When I said that, like, they wanted the variable taken out and you had to go update all the documentation and it took 15 minutes, I didn't do that. I didn't go and update the documentation knowing that my next slide was going to be about putting the variable back in and having to go back and put the variable back in. I didn't spend 15 minutes on either side doing it, so I misled you. I'm sorry. But the point is, using rmarkdown, it doesn't have to take that long. And I know that because I've already updated the documentation. That now my random number seed is 2200, not 100. That my test result is 4.76 and 3.73, which is 4.76 and 3.73. Because the documentation that I had before, I updated it with all the values that we got in the discussion. So now it's ready to go. But I still need to make some slides. So, Alex, dear manager, what do you think? Should we implement the random forest, the linear model, both or neither?
Well, I think we should implement random forest.
Random forest? Excellent choice. Do you know why? Why do you think? What information will you need when you go to present why we've done a random forest, that these are the reasons?
Performance of the model compared to linear model.
Now, there's a good chance I'll be making typos here, but that's fine. Excellent. Anything else?
It sounds cool.
It sounds cool. Excellent. Anyone else? Any other reasons why we want to include the linear model? Anything else that will help you as you go to present to your executive team why the random forests are best? Yes?
It's powered by AI.
Powered by AI. Excellent. Powered by AI.
That's why.
Powered by AI. Great. And so you do this, and you go through, and then you tell it to build the slides. This will hopefully kindly tell me that the slides are generated, and you think that's odd, nothing's happened. But here's a list of all the files that I've been working with today. I had an initial write-up, which was the first thing you saw when I started my Shiny app. I have a markdown file for initial write-up, which I then called with parameters, which were all of the results I showed as I was going through my Shiny app. And that led to Shiny Update 1, the HTML file. If we went through it again, there'd be a file called Shiny Update 2 with all of the documents, all of the results included. Then there's 4 markdown files for both linear model, neither, and random forest. Whichever one he chose, I had a template ready for it. And in particular, there's a slides out, which I'm now opening PowerPoint from within PowerPoint. Let's see how that works. I can put it on my screen. Let's put it on your screen, if I can find my mouse. Which says that we're going to implement random forest. It was held on the 13th of November at 6:32, which is when I hit the button, by Craig. Craig there is the login from this machine. So if this was being hosted by someone else, or if your manager was doing this, or someone was conducting this meeting on your behalf, it would have their employee ID there. The decision was reached to implement a random forest because of the performance of the model compared to linear, because it sounds cool and it's powered by AI. And then the next steps to validate the code and move on. The only thing that I couldn't prepare beforehand was this, because I don't know the rationale for making the decision and the information that my N+2 would need to convince his superiors. But because our markdown works with parameters, I collect the information from my Shiny app, pass those parameters into our markdown, and it comes out the other side as part of my slides. So as a result, in the one meeting, I pre-prepared all the documentation, waited to get all the information to feed into the documentation, and now we're done. So if I look at that and try to draw some conclusions or actionable insights from all of this, at the beginning I showed this infographic of what it means to be a modern data scientist. And this was from 2.5 years ago, so what's happened in those 2.5 years? And this is my opinion, that when I look at jobs and other things about data science, the emphasis tends to be on math, stats, programming, and database. In the 2.5 years, a lot of tools have been developed for programming, database, and visualization. When I wrote this the first time, I was using BaseR. Tidyverse has been a tremendous improvement in our programming. When I wrote this, tidy models hadn't been developed yet. This allows me to incorporate different configurations in multiple models very quickly. But in my opinion, the main challenges are in the domain knowledge, soft skills, and communication. And so there's this gap of soft skills and communication, well, and domain knowledge, but I'm not going to encourage you to go out there and learn every domain. When you get a job, learn the domain knowledge there. As a further example, I've worked in credit risk at 2 large institutions in Melbourne, and even though my job title was the same, the industry was the same, the cultures at those 2 institutions were very different. And so when you're talking about domain knowledge, that's not just the technical knowledge, but also the culture and the institutional way of doing things wherever you land a job. So if I'm talking to beginners and what skills should you learn, my first recommendation is negotiations. And most people think that when you start a job, they offer you some salary and you want some other salary, so you negotiate. Well, yes, but that's not what I mean here. In negotiations, you learn more about getting to yes and understanding what's important to different people, which I said with Alex that I wanted to change the frame from a technical point of view to an ethical point of view. The concept of a frame is a negotiations concept. When I'm talking about the documentation, if you can agree on a template, you can update everything. How do you agree on the template? How do you decide what's important to all of your stakeholders, so that you can give them the information they need. User experience, so HTML, CSS, etc. The Shiny app I showed you utilized a Bootstrap theme, the Darkly theme, but in general, because it's a web page, you can customize it with CSS, logos, color schemes from your industry. Wherever you're working, you can make that app look like it belongs to them. So even if you don't want to be the person talking to the stakeholders, you can try to gain some skills to help whoever will be talking to the stakeholders to make their jobs easier. My final recommendation is typing. Oftentimes the limiting factor for me is my brain to keyboard interface. And so if you can smooth that over, it'll help you whether you go into programming, program management, or other documenting points of view. The other thing I'd recommend is processes. Now my simple define, do, decide, document, done is a process. But if you want something more formal, that includes things like the Microsoft Teams data science process. If you look up their information, this is a process map of what it means to do data science. And all of the talk about whether you're using a linear model, a random forest, a neural network, doing all the fitting of metaparameters, that all lives in this one box. Although it gains most of the hype and most of the discussion, it's actually a small part of what a data scientist does. If I zoom in on the role of the data scientist there, maybe you can't see it in the back, but in certain places there are these back and forth arrows, or arrows that go backward. And whenever I see that in a process map, that's my cue that that's a good place to use Shiny. Because if you're expecting some form of iteration, if you're expecting some form of back and forth, set it up in such a way to make that easy. And if I look at all of the boxes about what a data scientist does, there's packages, or perhaps packages of packages, to help do that. Now it's not entirely fair because within tidy models you get the yardstick package. But if I count, there's 4 uses of Shiny and 3 uses of rmarkdown. Another process is so-called CrispDM. And here's a visualization of that process. And once again, you get these backward arrows, or backward and forward arrows, which is an indication to use Shiny. But something specific to the CrispDM process is this idea that the entire thing is a circle, which means you can use Shiny everywhere. And while data science gets all of the hype, I've seen job ads that say, do you know Tableau, Power BI, or Shiny? Because Shiny gets used as a BI tool, not a data scientist tool, or not an analytics tool of sorts. I've seen people using Shiny for scenario evaluation, forecasting, capital improvements. There are many more use cases for Shiny than simply data science, machine learning. And if I look at a list of all the packages, this is an infographic comparing the top packages in Python, Scala, and R. The colors are types of packages. The blue, which is in Python and Scala, is for mathematics and engineering. And while that's missing from R, there is this color of reproducible research, so rmarkdown. And while the academics or data scientists tend to view it as reproducible research, from an industry perspective, this is documentation. This includes things like model documentations and slides like I did for Shiny. Regulatory reporting, you can do in rmarkdown. Once you view rmarkdown as functions with parameters, now your documentation is a function. Now you can automate your documentation. Quarterly filings for the stock market, the SEC in the US, I think it's ASIC here, right? You need to provide quarterly advice as to your financial statements. rmarkdown. One of the use cases for machine learning is to generate a list of customers so that they might have different propensity to answer a marketing campaign. And so you get a lot of people talking about using AI and machine learning for that, which then typically, as a data scientist, I build a model, I get a list of potential customers, and I hand it off to someone else, probably in a CSV file in an email. But as an R user, it doesn't need to stop there. Because once I have a list, I can use data manipulation techniques to get that information for each customer. And when I have that information for each customer, I can use data visualization techniques to provide personalized information for that customer. And as I did in my example with multiple templates, if you have multiple classes of customer, you can automate the documentation for each customer. And now I have an entire user experience, user journey in R. So now I have an automated way to document and provide insights to customers, and I can take that further. With case statements, I can look at the demographics of that customer and attach images that look like them. So if I'm talking about older customers, attach an image of older people. Younger people, attach an image with a younger person. This isn't complicated programming, but now I'm creating personalized insights, personalized communication using open source, freely available software. And because everything's in R, the skills transfer. So if you're a data scientist and you want to move more into the business and do something more business intelligence side, you want to create dashboards and understand more of what's going on, you go from using R for data science to using R for the business and vice versa. Because everything's in R, everything's based on text. Everything's based on text, everything can be put under version control. Everything can be maintained in a central fashion so that it's not all sitting on someone's laptop. Because everything's in R, you can leverage other tools from R, such as test that. And now you have a standardized way of doing unit testing across the business. Because everything's in R, when you get grads coming on, straight out of school, learning R, they can do a rotation and learn every aspect of the business. And while we could argue whether or not R is the best for any one of those, don't underestimate the benefit of using a single tool across everything, especially when that tool is free. The other thing to think about is so-called business acumen. When I was going over the plots of my training data and I said, I know this isn't enough, I didn't mean anything about statistical tests or standardizing my variables, all of which may be necessary, but what I meant was, what are the business metrics? So if I'm looking at house prices and to use closer to Sydney values, I run my model and I get $1.5 million. This is the value of the house, and I show up to auction and I'm ready to go, and the first bid is 1.7 million. Did I do something wrong? Did I undervalue the house? Did they do something wrong? Did they overvalue the house? If I'm a buyer, this is a problem. I need to decide what to do about it. If I'm a seller, this is great. I just made an extra 200,000. So the use of your model, whatever it is, and the outcomes of it are going to be very important, and which side you're on matters. So whether you're talking dollars, customer take-up, net promoter score, whenever you're building a model, it should have some direct relationship to a business outcome. And if there isn't one, why do you need a model? And then you get a lot of business terms like lean, agile, management by objectives, total quality management. These things come and go. I was talking to my father about preparing this talk, and I asked him what were the big things, and he said management by objectives. I'd never heard of management by objectives. He was saying that all of the engineers were going to training sessions to learn this, and it was the greatest thing. I've seen a lot of these things come and go. But they all have common elements, such as understand the process, optimize the process, remove bottlenecks, which is the overall aim of my talk. But in general, the problems aren't going to be technical, they're human. All of this code is up on GitHub, and I have no doubt that if you currently use R, between using my code, blog posts, Kaggle kernels, Stack Overflow, official documentation, you could get all of this running in a week or two. But changing from I report to my manager and he goes and socializes the numbers with his cohort and comes back to me, and I make changes to instead say, no, what information do you need? I'll make sure you get that information, get everyone in a room, and we'll decide. Takes years. So if you have any questions, if you want to talk to me more about this, if you're ever in Melbourne, connect with me on LinkedIn, we'll go get a coffee. This talk and the previous version of the talk and all of my other talks are up on YouTube. I do have some kernels up on Kaggle. They're all in the same vein of this. It's not about pushing to get the best possible score. It's about trying to understand things from a business context and trying to explain what I consider to be necessary parts of documentation, not just whoever gets the best metric wins. These slides and all of the supporting code are up on GitHub. There's a Breaking the Bottleneck Sydney repository. So if you want to have a look at how I did any of the little tricks here, feel free to pull it down. Thanks to the Sydney users of our forum for the invitation and hosting this event, and of course to Jiffy, because there's so many GIFs and so little time. And for all of you for your attention and patience. Thank you.
Please join me in thanking Craig for